Thermochemistry, Hess's law. The statement of Hess's law is given to you. It is basically saying that the enthalpy change of any reaction only depends on the initial and the final stage, the products and the reactants, and is not dependent on the pathway or the number of steps it takes to start from the reactants and reach to the products. It is basically a restatement of the fact that enthalpy is a state function, not dependent on path. Let's say you want to find the heat of reaction associated with the change A to D. Now, instead of actually having to do this reaction, if you knew some other reactions that could lead to D, so let's say A forms B and you know the change associated with this. Then let's say B converts to C and you knew this change. And C converts to D and you know the value of this change. If all of these are known to you, then you don't need to actually go ahead and do this reaction and figure out the change in enthalpy associated with that. You can simply add up these equations and you see that when you add up the same thing, just like in math, if there is +2 on left and on the right side, you can cancel that. We simply add up these equations. All that is left is A forms D, which means that you can also add up the delta H values. It would simply be delta H1 plus delta H2 plus delta H3. So we are saying you don't actually have to do this reaction to figure out the delta H value. Now, the types of questions you will get on a test will always give you the target equation, and they will give you the steps that eventually lead up to making the target equation. So these equations will be given to you. Of course, these equations will not be given in the way where you just have to add them up. You might have to make some manipulations on those equations. So let us remind ourselves of the two properties of delta H. If an equation is reversed, the sign of delta H is also reversed, which means you multiply that whole equation by -1. You started something with the reactants, but you can rewrite it so that these becomes the products, and what were initially the products become the reactants. You simply change the sign of delta H. And the value of delta H is proportional to the number of moles, the amount of the reactants and products, I guess also, which means that if you multiply an equation with a number, so let's take the same equation, H2 plus half O2 forms water, delta H is -241.8. So if I multiply this equation by 2, then all the quantities get multiplied by 2, which means I would have 2 moles of hydrogen, 1 mole of oxygen, forming 2 moles of water. I'm sorry, I did not write the states. So then the delta H value will also get multiplied by 2. So this would be kilojoules. So sometimes it looks like the target equation is not given to you, and that's because you are expected to be able to write the target equation on your own. Some examples of that expectation could be if the target equation is a combustion reaction. So you're expected to know that whatever it is that you're combusting, the products are always carbon dioxide plus water, and your teacher is expecting you to balance that equation as your target equation. The other case where the target equation may not be given to you is when the target equation is an equation of formation of something. So in that case, you have to remember that the formation happens from elements in their standard state, and you get 1 mole of product formed. So those are the only 2 conditions where the target equation is not given to you. Let's look at this example now. So we are given some series of equations and we are given a target equation. So this is what you want to reach. So the first thing I suggest you do is look for what is present on the reactant side. So there is a C3H4. Let's go into the equations that are given to us and find C3H4. Okay, this is on the reactant side. This is where I need it. So maybe I don't need to manipulate my equations for this particular entity. Let's look for H2. H2 is on the reactant side. And where do I find H2? Oh, perfect. This is also on the reactant side. It is also the correct number of moles. I don't need to worry. Let's look at the product C3H8. Where do I see C3H8? Oh, this is on the reactant side, but it is needed on the product side, which means I might have to reverse the direction of this reaction. And then I've got a lot of other entities that I might want to get rid of. because I don't need them in my equation. So in this case, it looks like if I simply multiply this with a -1, which will mean that I also have to change the sign of my delta H, that might be enough. So let me rewrite that. So I'm reversing the equation. So 3CO2 plus 4 water. And please don't copy my bad habits. Do write the state. Don't do as I do, do as I say. And the delta H value becomes a positive kilojoules. Now let's see. Does this work out? It looks like to me that it is working out. So I'm just going to write my other equations as well. And now you see that we can cancel some things out. So there is 4 plus 1, 5 oxygen on this side and 5 oxygen on this side. So we can cancel all of that. Let's look at water. There is 2 plus 2, 4 water here and 4 water on this side. So we can get rid of that. And carbon dioxide, there is 3 carbon dioxide, 3 carbon dioxide on this side. So we got rid of that. And now when we add up these equations, what do we get? All that's left here is C3H4 plus 2H2 forming C3H, which is exactly my target equation. So that's good, which means all I have to do to the delta H values is if I call this delta H3, 2 and 1, then I have changed the sign of delta H3 and I'm adding delta H2 and delta H. So this would eventually be minus becomes plus, there is a negative, and let me get a calculator for that. Getting minus 288.6 kilojoules. This negative tells me that heat is being released. Let's do one more problem together. Okay, so the question is saying determine the heat of formation of liquid hydrogen peroxide at 25 degrees from these thermochemical equations. So, like I said, there could be 2 conditions where you're not given a target equation. This is one of those. So you should write for yourself the target equation. So this is the heat of formation, which means that you would produce only 1 mole of the product, hydrogen peroxide, H2O2, liquid. They have told us that. And this must be formed from elements, hydrogen and oxygen, in their standard states. So the standard state for hydrogen is diatomic H2 and oxygen is O2. So this is the target equation that we are looking for. Now let's look at all the equations that are given to us. And I like to first identify if I have any of the reactants and products in the right place. So let me look for that. So this looks like hydrogen is in the right place because it needs to be on the reactant side. Let me see if I see oxygen in the right place. Yeah, I see oxygen in the right place too. Oh, this is good. What else? I am looking for H2O2 liquid and I'm finding it here, but it needs to go on the product side. So that right away tells me that I will be multiplying this equation with a -1, which is basically saying I'm reversing the equation, changing the sign of delta H. So another thing I like to do is just label my equations. So let's give them numbers 1, 2, 3, 4, 5. And also label the delta H values. This is so I don't make a mistake when I'm adding things up on a test. Now let's look at what things we will need to change or move around because there's a lot that we want to get rid of. So pretty much everything else we want to get rid of. We only want to have these 3 entities in our final equation. I have decided that equation 5 will be multiplied by -1. Let me see what else happens. Look at 2. 2 has water gas on the right side and I want to get rid of this water gas that is in equation 1. So what if I multiplied my equation 2 with a -1 as well? So I'm going to use the same highlighter and say if we multiply this with a -1. So then I will get rid of my H2O values. Well, then it will give me the 2H and O on the right side, which is good because then that will cancel away with these in the products. So that's good. Something else needs to be done here. We are not done. So it looks like we would have to multiply this with a -1 as well so that we can get rid of this 2O. Will not be enough just here. So let's actually write this out. In some sense, this is trial and error, but you will get better at it the more problems you try. So I'm going to write 1 as it is. I am reversing 2. So I will write the products as reactants and reactants as products. I'm keeping 3 as it is. I'm reversing 4, reversing 5. Okay, let me now go ahead and cancel the things that can be removed. So whatever's on the left side and the right side gets cancelled out. So I see this first. There really isn't a rhyme or reason. You can just cancel out things as you see them. Okay, so as I'm trying to cancel this out, I see that there is a problem. And the problem is there is this extra O here and there are 2 O's on this side, but there's only 2 of the O's on the left side. So that alerts me to I've done something wrong. How can I fix this problem? Well, I want to have only a total of 2 nascent oxygen, which is just the oxygen atom on this side, but I right now have 3. I have to get rid of one of these. Hopefully, you're also seeing that I have half an oxygen here, oxygen molecule, and I have another 1 complete oxygen molecule. Let me look at my target equation. My total required is only 1, but I have 1.5. So I want to get rid of half an oxygen molecule on the left side, and I want to get rid of 1 oxygen atom on the right side. What's the easiest way to do that? Well, instead of multiplying equation 4 with 1, what if I multiplied equation 4 with half, which is I'm reversing the equation and dividing it by 2. So if I do that, let me write that in a different color here. So if I get half of O2 on this side, and I will have only 1 O left on this side, which works out nicely now because that means half, let's use a different color, which means half O2, another half O2 will make 1 full O2, which is what I need. And this 1 O and this 1 O cancels out neatly with the 2O on this side. So that works out perfectly well. Let me add up everything and that should give me my target equation if I've not made a mistake anywhere. So I'm left with H2G plus, notice the half O2 plus half O2 gives me 1 mole of O2 and nothing else left on the reactant side. To the products, I've cancelled out everything. I'm left with H2O2 liquid. So I will add up the delta H values too. So they will be delta H1 minus delta H2 plus delta H3 minus delta H4 minus delta H5. And now you can simply plug in your numbers from here and find the value. The thing to remember is that on a test, you want to show your thinking. You don't want to just write the numbers. It's very hard for a teacher to see what you've cancelled out, what you've kept, but it's really important that you write this part. This is your thinking, and this is what teachers are looking for on a test or on the AP exam. You don't know who's marking your paper. You want to be very clear that you show them what you were doing. And this part, just plug in the numbers. Give me a second. Let me get a calculator, put in these numbers and figure it out. I am getting minus 686.13 kilojoules. You can check that math and let me know if I'm wrong. Let's stop here. Try the other Hess's law problems given in the handout in your textbook. If you have any questions, come see me.